Sector of a circle is the region bounded by an arc of the circle and the two radii to the endpoints of the arc. To find its area, just simply get the product of the ratio measure of the arc over 360 degrees and the area of the circle. You can think of the sector of a circle as a part of the pizza. Let us take this given. Find the area of a sector of a circle given below. So what is the area of this shaded part right here? Let's say if the radius of this circle is 4 meters and the measure of the arc is 80 degrees. Step 1, we're going to determine the ratio. To solve for the ratio, just get the measure of the arc, which is in this case, it's 80 divided by 360 degrees. Then simplify. So since 80 and 360, its GCF is 40. So 80 divided by 40 is 2. 360 divided by 40 is 9. So we just simplify this 80 over 360 into 2 nines. Step 2, find the area of the whole circle. So recall that to solve for the area of a circle, we're going to use this formula A is equal to pi r squared. Then substitute r with our given radius, which is 4 meters. So simplify for m squared, that is 16m squared. Then multiply it with pi, and this gives us 16 pi meters squared, and that's the area of the whole circle. So if the area of the whole circle is 16 pi meters squared, and this part is only 2 ninths, so to get the area of this part, we'll just simply multiply them. Alright, so 2 ninths times the area, which is 16 pi meters squared, and we can get 32 over 9 times pi meters squared. But if you want our answer to be written in decimal form, so we can replace pi by its approximate value, which is 3.1415 times 32 divided by 9, and you will get 11.17 meters squared. So any of them are accepted as an answer. When we say segment of a circle, it is the region bounded by an arc and a chord joining its endpoints. So this shaded part right here is the sector of a circle, but this dark shade of red is called the segment of this given circle. Now, what if we want to find the area of its segment, this dark shade of red? So given the measure of the arc, which is 90 degrees, and its radius, which is 5 meters, so that's enough for us to solve for this one. So we will start by finding the area of the sector. So we learned in our previous example on how to solve for the sector. So since we know that the whole circle here, since the radius is 5 meters, so multiply it by itself, so that gives us 25 pi meters squared. Since 90 degrees, that is the measure of the arc, so it means 90 is 1/4 of 360, 1/4 of the whole circle. So it means the sector is 1/4 of the whole circle, which is 25 pi meters squared. So just simply multiply them, which is 25 over 4 pi meters squared, and we can get the area of the sector. So this shaded part right here is 25 over 4 pi meters squared. Next step, we're going to solve for the area of a triangle. Why? Notice that a part of a sector is a triangle. If we're going to remove this triangle, we will be left with this dark shade of red, which is the segment of a circle. So recall that in solving for the area of a triangle, we will just simply multiply the base times height, then divide it by 2 or multiplied by 1/2. So our base is 5. Our height is also 5. So 5 times 5 is 25. Then times 1, 25 divided by 2. This gives us 25 over 2 meters squared. And that is the area of this light shade of red, which is a triangle. We will then subtract the sector minus the triangle, and we are left with this segment of a circle. So the area of a sector is 25 pi meters squared minus the area of a triangle, which is 25 over 2 meters squared, and we can get an approximate value of 7.135 meters squared using our calculator. So 25 divided by 4 times the approximate value of pi, which is 3.1415 minus 25 over 2, and this will be our answer in decimal form. Lastly, the arc length of a circle is the region bounded by an arc and a chord joining its endpoints. So the length of an arc can be determined by using the proportion a over 360 is equal to 1 over 2 pi r, wherein a here represents the degree measure of the arc, r is the radius, l is the arc length, 360 degrees, that is the measure of the whole circle, and 2 pi r is the circumference of the circle. So let us take this given example. If JL measures 30 degrees as the measure of the arc, and the radius is 8 centimeters, what is the arc length of this given arc JL? So the opening of the angle is 300 or 30 degrees. But we are interested on the length. How long from J going to L? So first, we're going to write the proportion, then replace. So our A here is the measure of the arc, which is 30, and our radius here is 8. Then simplify, 2 times 8, and that is 16 pi. Now, since we want to solve for L, which represents the length of the arc, we're going to multiply each side of the equation by 16 pi because we want to isolate L. Then, multiply 16 times the approximate value of pi, which is 3.1415, times 30 divided by 360, and we can get 4.19. And that is the approximate value of the arc length of this given circle, 4.19 centimeters.